For our embedded system course, we wanted to make a smart water dispenser. When we thought about this approach, we wanted to help in saving water. However, this approach can be applicable to many different things, such as watering plants or for handicapped people. So our prototype works as follows. First, the person has to put a cup or container over the pressure sensor. Then the water pump starts working and starts dispensing a fixed amount of water. And when it's done, the person is alerted with a buzzer alert to let him know that his cup is now filled and ready to be used. Throughout this video, we're going to show you a prototype demonstration, a circuit connection, and some of the challenges we faced. First, we're going to start by the circuit connection.
So now we're going to be talking about the hardware connections and how this connects to our software and the logic of our project. So first we have our Arduino. We're going to be connecting everything to it. And first let's start with the force-sensitive resistor. The way we connect this is we put it on a breadboard because its ends are hard to latch onto the jumper wires. One end from the sensor is connected to the pin voltage in the Arduino, which supplies the sensor with 5 volts. The other end is connected through a 10k ohm resistor to the ground, and the part between the 10k ohm resistor and the sensor is connected to pin 0 of the Arduino.
Pin 0 is an analog input. The code reads the pressure value from the sensor through the analog input. And as we continue the demonstration, I'll be explaining how this will trigger the rest of our circuit.
Next we have our relay module.
And why we need a relay? Because we have two circuits. The first circuit is the Arduino circuit, and it has a voltage of 5 volts. The other circuit is the water pump, which has a voltage of 12 volts. And the relay will act as a gateway between them.
Okay, so how we connect the relay is actually quite simple. On the circuit side, we have one output that is directly connected to the ground. The other is the input to the relay, which is connected to one of the output pins on the Arduino. And the third one supplies the voltage to the relay, which is a 5 volts. So it's also connected to the Arduino. On the other end, the relay is connected to the water pump circuit. One is through the common and the other is through the normally open connection.
The water pump is a very simple circuit. It consists of the water pump itself and the 12 voltage. Here we have 8 batteries of 1.5 ampere connected in series.
The last thing we need to connect is the buzzer. And the buzzer has one connection to the ground and the other is connected to an output from the Arduino to the input signal in the buzzer. How this all works is
the sensor gets a certain amount of pressure and sends it to the analog input. And it will send a high signal to the relay, so the relay will close the circuit in order for the water pump to operate. And after a certain amount of time defined in the code has elapsed, the Arduino will send a low signal to the relay, so it opens the circuit in order for the water pump to stop.
Finally, the Arduino is going to be sending a high signal to the buzzer.
It will emit a sound to notify the person filling the cup that his cup is now full.
After we have seen the circuit implementation and the demonstration of the prototype, I will walk you through the 3 major problems we have faced during our project. The first problem was with the buzzer module. When we connected the buzzer module, it wouldn't work, though our connections were correct. With a simple experiment of switching the input signal to the buzzer module and the negative signal to the ground, it worked. So it was basically a problem in the manufacturing of the buzzer module itself. The second problem we faced was having the Arduino output 5 volts, while the pump needs 12 volts to operate. So we basically had a low voltage circuit that needed to operate a higher voltage circuit. And for that we used the relay. The relay is basically a switch that connects the two circuits. The relay is normally opened. Once the Arduino outputs the 5 volts to the relay, it closes operating the pump circuit. Our third problem was with our FSR pressure sensor. Our FSR pressure sensor is too small to sense the pressure of the cups present on it. So for our prototype demonstration, we just press on it with our fingers to supply pressure. This was a quick walkthrough our project implementation.